this. We've got practice problems on here. And with Ohm's law, it's a 3-variable equation. So many of you could read through some of those practice problems, punch something into a calculator, and come up with an answer. When we're doing practice problems in this class, we are not so much just trying to get an answer as we are practicing good problem-solving habits. So that's going to be really, really important that we talk through and we practice, hey, how do we set up a practice problem and why do we set it up that way? Even if you could turn the page and you could go, oh, wait a minute, I can read this, I can plug numbers in a calculator, and I can give you an answer. That's not really what we're working on. We're working on setting up, practicing good problem-solving habits, making sure you understand what you're doing, and you're setting up habits that when it gets more complicated later, you already got good, habits set up that's going to make it easier. There is there's one particular honors test later in the year that the math is more difficult than what we've done to that point, and those kids, as a teacher, it's the most painful test to watch because I watch them read that question. Every single kid reads that question and goes, holy cow. Then the kids that have practiced these good habits here, they go, okay, well, at least I can list my givens. And they list their givens. And then they go, and then I can see their brains go like, oh, wait a minute, I can do this. And then they can do the next step. And then they go, oh, wait a minute, I can do this. And then they can do the next step. The kids that haven't practiced good problem-solving habits, they just sit there and they stare at it. So we are really, really working on practicing good problem-solving habits. So even if math comes easy to you, and you're like, I don't want to do all this. This seems like a lot of steps. I can just punch in a calculator and answer. For now, you just need to trust me that this is really important that we work on this. At least by the end of the year, if you look at all the equations on the sideboard, you could get problems that could be any one of those equations. And you don't necessarily know which one it is when you right away read the answer or read the question. If you are an engineer or something like that and you're trying to solve like real problems, you don't necessarily have like, okay, well, it's going to be one of these 5 equations. You might have 5,000 different equations that you have to work with. And you're not going to know what to do unless you first look at, okay, well, wait a minute, what do I have to work with? And then that gets me kind of a step further to, well, maybe I can use this equation. And that's what we're practicing here, is setting up good problem-solving habits so we start with a step that we can always do, even if we don't know what the equation is. So before we even get to problems, we're going to think through some of these things. So things to think about. Making sure you know the difference between a variable and a unit. And that as you read a problem, you can identify which one is the variable and which one is the unit. So, for example, my example that I use, like, hey, if I live 7 miles away from town, that means that what am I measuring? The variable is distance, how far. The units I'm measuring it in might be miles or meters or feet or kilometers. So, example, distance is what we're measuring. That's the variable. What are we measuring? And units is what are we measuring it in? And could be measured in the units. Meters or feet or miles or kilometers or whatever units we're measuring it in. Distance is what we're measuring. That would be a variable. Could be measured in the units, meters, feet, kilometers, inches, millimeters. What's another example of variable versus units? Something else we can measure. Time, yeah. How long does it take me to drive to school? Time is the variable. It's what we're measuring. And I could measure that in the units, minutes, hours, days. Variable is what we're measuring. And then what units are we measuring it in? Okay, next one. Follow units through every single step. You need to have units on every single step because we can do any math we can do on numbers, we can do on units too. So remember at the beginning of the year, we'd practice some of that anything divided by itself is 1. When we do equations here, that means that if we have units that could cancel, well, that's going to matter. And our units are going to help us understand what it is that we're doing. Especially as you get to more complicated math, as you follow your units through, it's going to tell you if you did it or if you did it right or not. It's going to help you follow through and make sense of what are you actually doing. Because physical science is basically an applied math class, but it's math in a way that you're actually using it for a practical purpose. You're actually using it to figure something out. So here's my example. I'm going to stick with distance. If distance is equal to 60 miles per hour times 2 hours, that means, hey, if I'm going 60 miles per hour for 2 hours, how far did I travel? Well, what should my answer be in? My answer should be in miles. If I want to know how far I went, what distance I went, if I went 60 miles an hour for 2 hours, my answer should be in miles. And when I look at my units, I've got hours on the top of a fraction right here and hours on the bottom. Well, hours divided by hours, anything divided by itself cancels, or is equal to 1, cancels. So it's going to cancel. My answer is going to be in miles. How many miles did I go if I went 60 miles per hour in 2 hours? Or for 2 hours, I guess. Yeah. I went 120 miles. That's a distance I would travel if I drove 60 miles per hour for 2 hours. My hours cancels. My answer is going to be in miles, which makes sense because I'm trying to figure out distance. Let's say you're doing this problem and you did the math on the units and your answer comes out in hours. Then you should go, well, wait a minute. I didn't do something right. Because I'm trying to solve for distance. My distance shouldn't be measured in hours. So then it makes you go back and go, okay, wait a minute. Let me check my math. Something's not right here. And remember, anything divided by itself, so that includes top of a fraction, bottom of a fraction, cancels. Okay, next one. Always practice actually punching it into your calculator when we do practice problems together. Don't just wait for somebody else to get an answer. So when we're doing practice problems together, make sure every single one of you also has a calculator in front of you and you're also punching it into your calculator for a couple reasons. One, if we're doing practice problems, like I'm doing practice problems on the board and you're all just following along with me, but nobody else is actually punching their calculator, chances are I'm going to make a mistake at some point. So hopefully everybody else is also punching it in their calculator and somebody's going, wait a minute, that's not what I got. And then we can go back and check. Second of all, make sure you know how to use your calculator. These calculators, we're going to talk about that too. Next one, your calculator's only as smart as you tell it to be. Be careful with order of operations, especially if you're using one of these little, well, yours is blue on the tables, but one of these little ones, there's not parentheses on here. So you need to be really careful when you're punching things into your calculator, making sure you know how to punch things into your calculator. Because if you always, every time we do practice problems, you just wait and follow along with me, and then you get to a test and you don't know how to use your calculator, well, that's kind of a bad spot to be in. So make sure that you know how to use your calculator. And then the next one, we're going to do an order of operations example. Okay, so this next one, I'm going to throw in some numbers here. Let's solve for this. Grab a calculator, punch that in. Remember that your calculator is only as smart as you tell it to be, so you need to be really careful with order of operations. So every single one of you should be punching this into your calculator. Okay, what did you get? Nathan, what'd you get? It what?
I don't even know how to put this in there.
Okay, so should we try that? Let's see, who has an answer first of all, though?
I can't really tell what number says, but I got an answer.
It's a lot of numbers. Who's got an answer right now? Melody, what do you have?
I don't think it's right.
Okay, so what do you have?
Huh?
What do you have?
1,138.3.
Okay, because, how many of you got that? Okay, so here's the thing you need to be careful of. Everything on the bottom here, look at everything on the bottom. That's all on the bottom of the fraction. So if you had a calculator that has parentheses, and if you have your own calculator you use for math and you want to use that in here, that's great. Do that. Like if you've got the ones that have a little bit bigger and they have parentheses, do that. That would be great. But if you're using mine, there's no parentheses on here. So the way that I would do this is I would do everything on the bottom first. I would do 4 times 4.184, and that gives me 16.736. Then I would clear it out, and then I would do the 19,051 divided by 16.736. And I get 1,138.3. Okay, what if I did this? Watch how I punch this into my calculator. What if I did this? I did 19,051 divided by 4 times 4.184. What do I get? Wait, that wasn't right. Order of operations here. 0, 1, divided by 4, and then times 4.184. What do I get? Something different. Because I need to make sure to tell my calculator that, hey, this is all in the bottom here. So be really careful when you punch that in, because your calculator is only as smart as you tell it to. Okay. Next one. List your givens first, then choose your equation. This is one that's sometimes hard for you guys, because especially like right now, we only have one equation. But this is part of that good problem-solving habits, is that we are always listing givens first. So what does that mean? That means when we read an equation, when we read a problem, that as we read through that problem, we identify right away in the problem what's there, what information is given to me. And I'm going to list that first before I even think about an equation at all. So very first thing I do is I'm kind of making an inventory of like, okay, well, what do I have to work with here? And what am I trying to solve for? Before I think at all about an equation. So why? If there's lots of different equations that you could be using, like by the end of the year, any ones on the cabinet, but again, if you're working in industry, you're doing this for real, it could be thousands of different equations. If there's lots of different equations, that could be used, you won't know which one to pick unless you first know what you have to work with. If there's lots of different equations that could be used, you won't know which one to pick unless you first know what you have to work with. And that's listing your givens, kind of creating an inventory of what information do you have from the problem. Okay, something else to think about that doesn't come up so much in this unit, but especially when we get to motion, like basic motion stuff like speed and distance and velocity and time and acceleration. Sometimes it doesn't actually say the variable in the problem. It doesn't say solve for time, but it might say how long did it take. So those are what I call like clue words. So if you are reading through a practice problem, what are some of the clue words that might not necessarily be the exact variable, but what does it mean? So what does it say? If a problem says, how fast did you go? What does that mean? What are you solving for? What variable? That means speed. That would be like a clue word. It didn't say the word speed in there, but you know you're going to solve for speed because it says, how fast did you go? What if it says, how long did it take? What are you solving for? Those are clue words that mean which variable. What are you actually solving for? How long did it take? You're actually solving for time. Yeah. And sometimes that can be hard to read through those problems and kind of interpret that. That say, okay, well, what am I actually trying to solve for here? How long did it take? That by itself isn't a variable word, but it means a variable. It means time. Okay, last thing then that I want to reiterate. Well, actually, we've got one more bullet point here. Make sure you're showing work on all steps. Show all work on all steps because that's going to help you figure out what are you doing, especially as things get more complicated. And then I want to reiterate, again, say, hey, practicing good problem-solving habits is as important or perhaps even more important than just getting the right answer. We're really, really working on setting up these good problem-solving habits, not just getting a right answer. Okay, so how do we do that? What are we doing? First thing we're going to do, we're going to read the problem, and we're going to start listing everything that we know from the problem. That's called the givens. Then once we have a list of those, then we look at our givens and we go, okay, well, wait a minute. This is all the information I have to work with. What equation am I going to use? Then we can take those givens and we can plug them into the equation. So let's try a couple of these together. We're going to skip this top part for the moment. Actually, no, because we need to know what's what. So I guess we won't. Okay. V is an abbreviation for what variable? What is it? Voltage, good. That's the variable. That's the what we're measuring. What units are we measuring it in? We're measuring it in volts, which we abbreviate with, again, a capital V. A capital I is a variable. What variable does it stand for? What variable is it? Luke, what is it? Capital I? Good use of resources. What is it measured in? It's measured in amps, and we abbreviate that with a capital A. So that's the unit we measure it in. What's the variable? Current. So current is the variable. We abbreviate that variable with capital I. It's measured in the unit amps. R is what variable? Alyssa. Resistance is the variable, the what we're measuring. And what unit are we measuring it in, Olivia? Yeah, that Greek letter. Do you remember how we read that? What the variable is, or what the units are? The units are ohms. And the way we abbreviate ohms is with that Greek letter omega. Would it be a good idea to abbreviate ohms with a capital O or a lowercase o for that matter? What does an O look an awful lot like? A 0, yeah. Omega right there, that Greek letter is the symbol that we use to abbreviate the unit ohms. Okay, now when we read a practice problem, sometimes I circle it directly in the practice problem. So this first one, what is the current? Okay, well that's what I'm going to solve for is current in a 10-volt circuit. 10 volts, well that's going to be the voltage. If the resistance is 2 ohms, so that's going to be my resistance. So right away as I read the problem, I'm looking for what information is given there. Then I make my list. What do I have to work with? Voltage equals 10 volts. When I list my givens, I'm always going to have variable equals number unit. I need all of those pieces to it there. Variable equals number unit. What else do I have to work with? Resistance is 2 ohms. Variable equals number unit. And then I also want to make sure I include what I'm trying to solve for, because that needs to be part of my list here of like, okay, well, what do I have to work with? Well, I'm also going to figure out how to include current. That's what I'm trying to solve for. When I write my equation, I want to write it out in the way that it's already set to equal what I'm trying to solve for. So our equations here are voltage equals current times resistance. That's the equation, that's the mathematical relationship for Ohm's law. But I'm trying to solve for current. So if I'm trying to solve for current and I have voltage equals current times resistance, I want to get current by itself. Right now it's being multiplied by resistance, so I'm going to divide it by resistance. If I do it to that side, I've got to do it to both sides. That resistance on this side is going to cancel, which means my equation is going to be current equals voltage over resistance. Okay, then I've listed my givens. I wrote the equation out set to equal what I'm trying to solve for. Now what I'm doing, the way I want you to think of this is I want you to think of this as, hey, you're just writing this exact same thing, but you're replacing any of the variables with what you know it to be. So current equals voltage, but I know voltage is 10 volts, over resistance, but I know resistance is 2.0 ohms. Make sure you got units on every single step. Now do the math on the numbers. (10) divided by 2.0 is going to give you 5.0. A volt divided by ohm is equal to an amp. We're measuring current in amps. Okay, I need to see real quick on the math skills here. How do you feel about the math part of this? Okay, let's skip ahead to one where we're solving for something different. Let's skip to, well, let's do 6. We're solving for voltage there. So skip ahead to number 6. We read the question first. As we read through it, often I'll circle directly in the question, like, hey, what information does it give me? So what voltage is required? I'm going to solve for voltage. To move 2 amps, 2 amps is current, through a resistance of 5.5 ohms. So what information do I have to work with? 2 amps, amps measures current, so current equals 2 amps. Resistance is 5.5 ohms. So I've got variable equals number unit. Variable equals number unit. And I'm trying to solve for voltage. So what's my equation? I'm trying to solve for voltage. Voltage is equal to current times resistance. Then I'm taking this exact same equation, I'm transferring it over here, but I'm replacing the variables with what I know them to equal. So voltage equals current. Well, current is 2 amps times resistance, but resistance is 5.5 ohms. Notice also how instead of like using a time sign or something like that, I always put everything in parentheses multiplied by each other. That helps me better keep together my units and my numbers. So I've got my number and my unit together. That's all goes together in one piece. Then I can do the math on the numbers. Again, make sure that you're always doing math on the numbers with me if we're doing practice problems together, that you're not just waiting for me to do that. So 2 times 5.5, either on your calculator or in your head, is going to be 11. And then the units, an amp times an ohm is equal to a volt. Well, we're solving for voltage, so that makes sense. All right, let me look at